Hello everyone, welcome to Ramail Padai. Today we are going to solve a question from Unit 10 Triangles and Quadrilaterals that are asked in year 2080 at Madhesh province. And the question says that a parallelogram MATH and a triangle SAT are standing on the same base AT and between the same parallel lines AT and MS. Okay, so we first need to construct a diagram or figure where triangle SAT and parallelogram MATH are standing on the same base AT and same parallel lines AT and MS. Okay, the first thing that we do is that. Now in A, write the relationship between areas of parallelograms standing on same base and between same parallel lines. So this is about theorem 1, which says that parallelograms standing on the same base and lying between the same parallel lines are equal in area. So this is what we will write in A. Now moving on to B, prove that area of parallelogram MATH is double the area of triangle SAT. So this is theorem 2 of our question. Okay, theorem 2 of our study in triangles and quadrilaterals. So theorem 2 states that area of triangle is half the area of parallelogram. That means the area of parallelogram is double the area of triangle. Okay, so we need to write this and prove this. Okay, so we will first construct a line and then write statements and reasons and prove that the area of parallelogram is double the area of triangle SAT. Okay, so this is what we will do. Let's move on to the solution then. Solution. First of all, we need to construct a parallelogram and triangle. Okay, so first I will draw two parallel lines. Okay, so I am drawing it with my bare hand, so there might be some bend lines as well, but suppose it as a straight line. Okay, so first we will draw a parallelogram. It is too wobbly. Okay, so parallelogram is MATH. So this is parallelogram because these opposite sides are parallel and equal, and these two opposite sides are also parallel and equal. Okay, so this is parallelogram. And what is said that same parallel lines AT and MS, AT and MS. So the parallelogram is MS, so S will be somewhere here, so that triangle SAT will be drawn. Okay, so okay, straight, somewhat straight, now straight as well. Okay, so this triangle SAT is also drawn. They are on the same base AT, and between same parallel lines AT and MS. So you have learned in theorem 2 that the base is on the base, but here let's flip the this figure horizontally, I think. Okay, so the base will be on the upper side, so here AT is on the upper side. Okay, so this is what the question says and what the figure means. Okay, now moving on to A, write the relationship between areas of parallelograms standing on same base and between same parallel lines. According to theorem 1 of triangles and quadrilaterals, you know theorem 1, right? So this is theorem 1. If you are wondering where these slides are, this is the concept video slides, and I have uploaded it on the YouTube channel as well. So please check the link on the upper right hand corner in YouTube, or search on YouTube the concept video, or you can watch it on the playlist as well. So that is where I have kept this video. So the theorem 1 says that parallelograms standing on the same base and lying between same parallel lines are equal in area. So according to theorem 1 of triangles and quadrilaterals, the area of parallelograms standing on the same base and between the same parallel lines are equal. So this is about the theorem 1 and about the question number A. Okay, now let's move on to question number B. Prove that the area of parallelogram MATH is double the area of SAT. Okay, so we will first write here, we will first write given as in this. So we will first write given, and then we will write to be proved, and then we will construct something, and then we will write statements and regions. Okay, so we will first write given. The given is this line, the question given a parallelogram MATH and a triangle SAT are standing on the same base AT and between the same parallel lines AT and M. Yes, okay, so this is what is given to us. Now to be proved, what you need to prove? Area of parallelogram is double the area of triangle SAT. So the area of parallelogram MATH is double the area of triangle SAT. Okay, now moving on to construction, because in theorem 2 we need to construct. In construction, in theorem 2 we have constructed a line so that the triangle become one half of the parallelogram. So we have constructed QT so that PQTU become a parallelogram. Okay, so now we will construct a line A somewhere to the point, this point, so that this becomes parallelogram. Let me do it on different color. So let's play with the color. Okay, so we will construct a line from A to this point. So this point will be STU. Okay, so U. Okay, so we will construct a line to this point. The line is straight. Okay, so that UATS become a parallelogram. Okay, so that this three line symbolizing parallel lines and these three lines symbolizing equal. Okay, so this is what we need to construct. So construction is construct a parallel line AQ parallel TS from A to any point U on M. Yes, okay. So what it says that construct a parallel line TS and AU so that U is on somewhere on the line MS. Why somewhere on the line? Because to become parallel, there is only one point where A can connect to U. Okay, so this is what it is. Now we will start to prove that. Okay, so there will be statements and there will be regions and there will be S and serial number as well. Okay, so now construct a table here. Use scale not on your exam, okay, otherwise it might not look good and that might be the reason for your less marks. Okay, so the first statement is parallelogram, area of parallelogram area of parallelogram MATH is equals to area of parallelogram UATS. Reason: the area of parallelogram standing, so this is theorem 1, okay, standing on the same base and between same parallels are equal. Okay, so this is the first statement. Now we will write the second one, and the second statement is about the triangle and parallelogram. So area of triangle SAT is equals to half multiplied area of parallelogram UATS. Okay, and why is this? Because the diagonal SA bisects the parallelogram UATS into two equal halves. Okay, now let's move on to statement 3, where it says 3 area of triangle SAT is equals to half multiplied area of parallelogram MATS. Why? Because in statement 1 we have write that area of parallelogram MATS and UATS are same. So we replace the area of parallelogram UATS with area of parallelogram MATS. Okay, so from statement 1 and 2, now we need to prove that the area of triangle is double. Okay, area of parallelogram is double the area of triangle. So we will multiplied both the side by 2, so that 2 into area of SAT is equals to area of parallelogram MATS. So 2 times area of triangle SAT is equals to area of parallelogram MATH. Why? Because we have multiplying statement 3 by 2 on both sides. So this is about our solution, and we have proved that the area of parallelogram is double the area of triangle. Okay, so we will write the final line. So the area of parallelogram MATH is double the area of triangle SAT. Okay, so this is about the solution of this question. If you have any confusion, please let me know in the comment section below, and I will try to respond to that query. And if you want the concept video, you can watch it on our YouTube channel and TikTok as well. So we will meet you in the next video. Till then, bye bye.